So we'll jump in down at the bottom of the notes page. dy dx means the derivative of y with respect to x. Well, we could also write this as d dx of y. That sort of means take the derivative of y. dy dx means the derivative of y with respect to x. We use it over and over again without maybe having specifically said what it means. dh dt means the derivative of h with respect to t. You could also write it like this. But here's the big deal. The denominator is important. It tells you what you're taking the derivative with respect to. That's going to matter a whole lot. Not quite as much today, but a whole lot next week. So we're going to start doing derivatives with respect to time. How do things change with respect to time? As opposed to how do they change with respect to x? Okay, top of the next page. Y equals 5x cubed plus 7x minus 10. Find dy dx. That's pretty easy. I want you to find it right here because we're going to do some other stuff over in that corner right there. So take 5 seconds and find dy dx. I'm not even going to press pause on the video because you should be done by now.
You know it's taking long.
So 15x squared plus 7, and then the derivative of 10 goes away. So 15x squared plus 7. No big deal, dy dx. What's going to be a little bit harder is trying to find dy dx if there's not y by itself, if there's a y squared. We're going to come back to that in a minute because I want to talk about chain rule because that helps me think about implicit differentiation, which is what we're about to do. Like that's the name of today and tomorrow, or today and Monday. So we're going to spend 2 days on implicit and 2 days on related rates. And yes, because they are kind of complicated, we'll spend 2 days on them. Your triangle doesn't need to be orange, but it just makes it more fun.
What's with the triangle?
What would the derivative of the orange triangle cubed be? Think about the power rule.
3
orange triangle squared. 3 orange triangle squared. But that's not it, because we don't really know what the triangle is. So we have to chain that onto the derivative of the orange triangle. That's a little bit like a piece of the bonus, right? Because the bonus had a tangent cubed in it. And so part of your answer anyway was 3 tangent squared and then secant squared. I hope that sounds familiar to a lot of you. It should, because a lot of you got that far. And so even if we don't know what the triangle is, we can still kind of take a derivative. We'll just leave this as the derivative of the orange triangle. So that's the power rule. Usually we use it for something easy like x cubed. So that would be 3x squared. And we usually don't even write the second or the last piece because it would be derivative of x with respect to x, and that would be 1, so we don't really write that out. Here's what we're going to do today though. Derivative with respect to x of y cubed. We haven't really done that, but we're still going to use the power rule and the chain rule. So maybe the orange triangle is most helpful. 3y squared. I don't really know what y is, so I'm just going to have to tag dy dx on to the end of that.
Is that what
So
differentiation?
Implicit differentiation is simply, that's maybe a little misleading to throw that word in there, but implicit differentiation is a result of the chain rule. If you use the chain rule on orange triangles, you get a d triangle dx. If you use it on x's, it's great. You get a dx dx, kinda not, because we don't write that. And if you use y's, you end up with a dy dx. So let's see if we can find, or what we'll try to find in a moment is dy dx off of something that has y squared in it.
That's scary.
There's really not enough room right here, so let's jump to example 1.
Okay.
Find the slope of the line tangent to the graph. Again, we like to just use a bunch of different words that all mean derivative. Find the derivative in terms of x and y. That sort of means our answer might have x's and y's in it. It won't just be x's. So let's kind of write some steps. Take the derivative of both sides. That may sound weird, but you can add that to the list of things you can do to both sides. Right? Like my oldest is in 7th grade. He's doing 2-step equations right now, so he's learning to add 7 to both sides. And then 2 steps later, he'll divide both sides by 5. Simple stuff. Later on, you learn to square both sides or square root both sides.
Yeah.
You've done that. Now we're going to take the derivative of both sides. So let's d dx both sides. And before long, you're not going to be writing this. Just like it's almost frustrating. It's fine. My 7th grader who's writing, and you remember when you first learned this, you wrote plus 5x, and then you added them, and then you got the next line, and then you wrote minus 3 and minus 3. And I'm just thinking, just add 5x. Like, stop writing it. But he's learning, so we're going to let him do it because he's showing his work. Same thing here. Like, we're going to write this a few times, and then we're going to be like, all right, just take the derivative of both sides. You don't have to tell me what you're doing. But that's what you're doing. You're taking the derivative of both sides. So we took the derivative of y cubed a moment ago. Still the power rule, 3y squared. But then the chain rule. And the chain rule, that's the biggest part of this. People will forget the dy dx. When a y shows up, don't forget dy dx. The other side is easy, 15x squared. And now it's just algebra. So I want to get dy dx by itself. Let's divide both sides by 3y squared. And since my 7th grader's doing this, we'll show the steps here. Dy dx equals, some of that will reduce, 5x squared over y squared. That's implicit differentiation. The only thing different about it, I mean, it is a big deal, but the only thing different about it is dy dx shows up as you take a derivative of y. Like, let's back up a second. Implicit versus explicit is about whether the equation is solved for y or not. Explicit is you have y equals, and so the right side of your problem is just y prime, or excuse me, the left side is y prime. Implicit is you don't have it solved for y. You've got, y squared plus sine of y plus e to the y equals something. And so you've got y not explicit, it's implicit and all there. All the rules are the same, it's just that if y shows up, dy dx has got to show up as well. So hopefully you know all the rules, because we're going to keep using all of those rules. Number 2, find the instantaneous rate of change. IROC, that's dy dx of y with respect to x, so that's change of y with respect to x, dy dx of this thing. So let's take the derivative of both sides with respect to x.
Is it okay if you algebra it first, or?
I don't know how you would algebra it first.
I just moved the x to the other side because it threw me off.
That would be fine, yeah. I'm going to show it one more time where I'm taking the derivative. Well, this time I didn't even write it on both sides. I'm taking the derivative of everything. So the derivative of y cubed let's pause. Time to resume. So yeah, I'm factoring out dy dx. So that leaves 3y squared plus 2y minus 5. I move the 2x over. I'm trying to get dy dx by itself. So I need to just divide by all of that stuff. So 2x over 3y squared plus 2y minus 5. So now I have dy dx. Yes.
Okay, so I know that we need to show that dy dx is on every clause of the y. So I'm just wondering if I can still get credit for doing this, but I moved the 2x to the other side, and then I had the parentheses of all the derivatives with dy dx like distributed into it, and then just divided it. It just makes the math like cleaner. Is it okay? Like, does that still count as credit?
So you move the
I just
2x over
skipped the
first?
second step, kind of. Yeah, I skipped the second step.
Or you just wrote this? Yeah, that's fine.
Okay, great.
Yeah. And Luna, you were saying you moved
Yeah,
the x squared over because like you saw ahead of time that all these have y's.
Yeah, and I was
So-
just like, that just.
I think I'll just keep all the y stuff together and the x stuff. That's fine too. Because you would have, I mean, you landed at the same spot, either one of y'all. So that's okay. You're kind of doing algebra in different places, and that's all right. All right, let's try number 3. Find dy dx if tangent of x equals x times 1 plus sine y. So I'm going to take the derivative of everybody with respect to x. I keep saying I'm not going to write it, but I'm still going to write it a couple of times because I'm taking the derivative with respect to x of both sides. What's the derivative of tangent of x?
Secant squared.
Secant squared. Now that was part of the bonus as well. Secant squared x. Dx, if you really want to go overboard with your emphasizing the chain rule, but dx is just 1. What about the other side? What am I going to have to use to take the derivative of x times 1 plus sine of y? The product rule. So this is a little bit crazy with x's and y's, so this might be a good one to write out the product rule. Again, some of you are starting to just sort of product rule in place. That's completely okay. But since this is the first one with implicit, so f is equal to x, g is equal to 1 plus sine of y, f prime would be 1, g prime, derivative 1 is 0, cosine of what? Dy dx. Anytime y shows up, dy dx is going to show up. So secant squared x equals fg prime. So x cosine y dy dx plus the other way 1 plus sine of y. And I'm finding dy dx, like there it is. So some algebra left. I'm going to subtract the 1, subtract the sine of y. And then divide by the stuff that's left, x cosine y. So you're going to get some goofy, weird answers today because it's a combination of all the rules you already know. So there's no new rules today. Really, there's no new rules today. It's just using the chain rule when y squared and y cubed and that sort of stuff shows up. Probably the simplest thing to remember about today, Haven, you said it, if there's a y, then dy dx is going to show up.
They're attached at the hip.
They're chain ruled at the hip. How about that? Find dy dx for this guy. So some of this is easy.
Would factoring be allowed here?
So if, I don't know that would even factor.
Well, if you move the stuff around.
You're welcome to move stuff around. If it factors, think about what that means. If it factors, you're going to introduce the product rule. So, yeah, it wouldn't be wrong, but I don't know that it would be worth it. So 9y squared dy dx. How about 4xy squared?
Heck if I know.
What's that going to...
Isn't
How
that
are we going to have to do that?
product rule?
It's a product rule. And you can attach the 4 to either one. I'll just attach it to the x and call that f. And y squared will be g. And feeling adventurous, let's try product rule in place on this one. So the first times the derivative of the second. The derivative of the second. Need the derivative of
8xy.
Well, don't jump to the end. Let's just go one step at a time here. Kicking out all the people who chose to drop. Miguel, what's the derivative of y squared?
2y dy dx.
Good. 2y dy dx. Good. And then the other way around, the derivative of the first one times the second one, so that one's just 4y squared. Then the derivative of 2x to the fourth, start to get easy again, or easier, 8x cubed. Derivative of 9x is 9. Belle, how about the derivative of 11y? Good, 11 dy dx. And then this one is just a pain algebra-wise. So I'm going to find all my dy dx stuff and get it all on one side and get all the non-dy dx stuff on the other side. It may be feeling really adventurous. Try to do all that at once.
You really feel like tested today.
Yeah. So all the dy dx stuff on the left and factor out the dy dx. And then everything else, anything that doesn't have a dy dx, moves over to the right. And then we'll divide by all of that stuff. Because there's all those different terms, when you're checking with each other or checking the key, it's possible you could put things in different order and still have the same answer, so be careful. The one that throws people off the most is if you move the dy dx to the different side than I do, then that changes all the signs. But it's still the same thing, it just changes all of the signs. So be careful. Number 5. Find the slope of the line tangent to the graph, so that's dy dx, at negative 1, 1. Okay, so this time, what's different about number 5 than the previous 4? I got a point to plug in. So it's going to be the same stuff, it's just when we get to the end, I'll have to plug in negative 1, 1. Oh, here's my orange triangle cubed here. So 3 times orange triangle squared. But I have
There's also the x.
to chain rule that. What's the derivative of x plus y? What's the derivative of x?
1 plus dy dx.
1 plus dy dx.
1 time.
Yeah, so the algebra is going to get yucky on this one already. The other side's not bad. Let's pull some popsicle sticks here. 3 terms on the other side. 3 volunteers for us.
Volunteers.
Callista, what's the derivative of x cubed?
3x squared.
Yep. Brandon, what's the derivative of y cubed?
dy squared dy dx.
Good. 3y squared dy dx. And then Kyle, the derivative of negative 6? Zero. It's supposed to be the easy one, but sometimes we forget about the constant and just leave it or do something else with it. But yeah, it's 0. Ugh. Although you can plug in now and then solve for dy dx, or you can solve for dy dx and then plug in.
Your choice.
Take your pick. You got a preference?
I did it the solve for dy dx first.
Math teachers would solve for dy dx first. I feel like most students would probably plug in first. It's fine either way. So I'll plug in. So negative 1 plus negative 1 squared. 1 plus dy dx equals 3 times negative 1 squared plus 3 times negative 1 squared dy dx. Like the calculus part of this problem is over. We are now doing algebra. Let's see, 3 times 4 is 12. 1 plus dy dx equals 3 plus 3 dy dx. Yeah, I'm going to have to distribute this 12 over here so that I can get all my dy dx's together. So, speaking of not showing my two-step algebra equations, if I subtract 3 dy dx, I get 9 dy dx. If I subtract 12, I get negative 9. So dy dx equals negative 1. Let's see if that's what I got last year. It is. Again, in some ways, hey, there's nothing new today. In other ways, like, it's a lot new. You gotta keep doing dy dx whenever you see it. Number 6, given x squared minus y squared equals 36, find, what's this mean?
Double prime.
Second derivative. And again, there's no way to jump to the second derivative. Like, there's no magic.
How to?
You just have to find the first derivative, clean it all up, and then find the second derivative. So, let's do that. Three terms, 3 helpers. 2 of them sitting next to each other can confer briefly. Brooke, what's the derivative of x squared? 2x. Might be the easiest one on the... Maybe, maybe not. Garrett, how about the derivative of y squared? Good, 2y dy dx. And Marissa, the derivative of 36? 0. Okay, not bad. Let's solve for dy dx. Although there is a way to do this, like in place, just hit it again. But I think most people would solve for dy dx first. So if I subtract the 2x over, and then divide by negative 2y,
2y or 2x.
I think I'm going to get x over y.
Yeah.
All kinds of skipped algebra steps there. So now let's do it again. Take a second derivative. Well, take a derivative again, and since we're doing a derivative again, we're going to get the second derivative. Uh-oh. What's happening on the right-hand side?
Yuck.
Quotient rule. Although not a terrible quotient rule, I don't think. Landon, if f is equal to x, what's f prime? 1. Peyton, if g is equal to y, what's g prime? Good, dy dx. And so now it's just the quotient rule, gf prime minus fg prime. Gf prime, so that's just y, minus fg prime, x dy dx, all over g squared, y squared. Are we done yet? Yeah, it says in terms of x and y. So not quite done yet. If only I knew what dy dx was, I could substitute in for dy dx.
Could you just divide by...
Oh, I kind of messed it up here. I did have dy dx. It was x over y. So I'm going to replace dy dx with x over y. And that looks okay. Like, free response, it's fine, because you've got it in terms of x and y. Multiple choice, though, they're going to clean that up, because they don't want fractions and fractions. So I could multiply the top and the bottom by y. So that would be y squared minus x squared over y cubed. Back up. Free response answer was that one. There's an extra trick to this. Our multiple choice answer is not going to be this. They like to do this trick where, let's see, y squared minus x squared. But this problem started by telling me that x squared minus y squared is 36.
36 over y cubed.
Almost. Y squared minus x squared.
Oh, negative 30?
Yeah, so if we switch things around, y squared minus x squared is negative 36. So my multiple choice answer would be negative 36 over y cubed. They really like that problem, and there's no way you would have, I mean, if you made it this far, that would be fantastic. And then they expect you to remember, oh yeah, that was equal to negative 36. That's why we always show you this as an example, because the best students would make it this far. Nobody would go that far. They would because this says in terms of x and y, this is an acceptable answer, but on a multiple choice, they're probably going to go.
Probably be able to figure that out.
Hopefully, if the multiple choice, your answers are 36 and negative 36 and some other stuff, and maybe you'd realize, wait a minute, what's going on here? And maybe you could figure it out. Let's do one more. Yeah, let's just do one more, because this creeps into what we'll do next week. Number 7. A spherical balloon is being inflated. Write an expression for the instantaneous rate of change of volume with respect to t. So what's it asking me to find? dV dt. 9
DV.
dV.
I thought you said VVVT.
dV dt. The formula for volume is V equals 4/3 pi r cubed. So if I want dV dt,
Better get cracking.
let's do d dt of both sides. So d dt of V is the same thing as dV dt. That's the easy side.
And here comes the yuck.
Other side, well, 4/3 pi is just a constant, so I'm not worried about that. I need to find the derivative of r cubed. So what's the derivative of r cubed?
3r squared.
3r squared is part of the answer.
She said dV dt.
She said the r dt. And so, clean that up a little bit, the 3's would cancel. 4 pi r squared dr dt. We'll pause to think about this more next week, but this becomes where one place where calculus becomes real world. I know you think, well, who cares about blowing up a balloon? But in some industrial situation, if the radius is changing at a certain rate, that means the volume will be changing at a certain rate.
Like a weather balloon or something.
Or maybe the other way might be more important. If you're injecting a certain amount of volume at a certain rate, you know how the radius will be changing.
Yeah.
So if you're pumping something into some spherical container, you can calculate how fast it's getting bigger. That's related rates. That's more for Tuesday of next week. All right, pause.